'Cause even when I'm low, He restores my soul.
Good morning, HVAC preacher here. As always, we thank the Lord Jesus Christ for another day and more opportunity. We have, it's about 7 o'clock down here in Louisiana. We have a call for a high temp alarm on a frozen food case. I'm excited to bring you guys along on the journey, on the troubleshooting process. I'll see you when we get there. Alright guys, we're walking up to the case here. This is our case 6B. The first thing I would do dealing with this, we got a high temp, is I'm gonna open up this door right here, check for airflow in the air curtain, and we do not have airflow at all. Let's check all the doors, make sure that it's not just a couple fans. You know, it's a mystery how some of these fans become unplugged. I've seen it more times than you can imagine. So we're just gonna make sure that it's not the fans here. Okay, I don't even hear the fans running. So what we're gonna have to do is pull all this product right here, get down to the bottom of the case, and go from there and see what we're dealing with. I don't hear fans running, but hey, it could be froze up. The fans could be stuck in ice. I've seen it 1,000 times. Drains are clogged. So we'll take it after they pull it. Hey, this is a zero zone case, and I just have to say something. I wish more manufacturers would make a case so easy to pull apart. I mean, this is just too easy to work on. You know, I'll say it, I might get chastised for this, but the truth of the matter is, when it comes down to these zero zone cases, these are very old cases, and I have less trouble with these cases than I do with the new style cases, all the Husband and Hill Phoenix cases. I mean, it is what it is. These cases are straightforward, very dirty in here, but as you can see, I got this thing opened up right here, and we have no fans all the way down. Doesn't appear to have any ice buildup, so we'll start troubleshooting. All right, we got the electrical panel opened up. Right here we have a, see if I can hold this and trace out this wire diagram for you. So as it is, 120 volts. We're coming in on 6 one side and 8 with the other side. Well, we know that we have no fans in our case, and what I mean is that they're not running. The case is not froze up, so the first thing we would want to check is, do we have power on 6 and 8? If we have it there, then we know that we don't have a breaker tripped or anything like that. I have my suspicions that a breaker is not tripped, because this is one case on a line of cases, and we have fans on our other cases. But because we want to be thorough, we just go ahead and go through the motions and check it. And let's see if I can do this right here. So we have 8 and 6. Let's see what we have. 120 volts. Okay, so we do have power coming in. So what we want to do is follow our wiring diagram. Okay, so 8 is our black, 6 is our neutral. So if we go through, we see the neutral goes directly to one side of the fans. Well, 8 doesn't go directly to one side of the fans. It comes through here on a purple, and it comes to this relay right here. Now this relay is energized in defrost to break the fan cycle. But whenever we're in refrigeration, this coil is no longer energized, so therefore 8 and 2 are a closed circuit. You notice they're wired normally closed. So in its natural state with no power to the coil, we have a closed circuit. So we need to check between 8 and 2 to verify that this is indeed closed. If it's not closed and we have no power to our coil, then I would say we have a bad relay that needs to be changed. But if it is closed, then we have to go further down the line. So before we get any further, let's go ahead and check 8 to 2. Now, this is one side of power. This is not a load. We're not checking a load. We're checking a open and close switch. So when an open and close switch is closed, like a gate on your fence, we have a connection. That means that we are going to read 0. Otherwise, if it was open, it would be the same as reading 8 to ground. That would give it, if this is open, it would give us 120 volts. If it's closed, we're essentially reading across the same line, so we're going to get 0 volts. Let's see what we can do. See if I can do this. Tell you what, give me 1 second and we'll check to see if this is closed or not. So we have the leads on 8 and 2, and as you can see, we have a closed circuit. Well, how can you verify that we're getting power across it? How do we know that there's actually power to it? Well, we verified that we have power to our 6 and 8, so we go through it and we can literally check 2 to ground. So with that being said, I'm jumping power from 8 to 2. So if I check 2 to ground, I should have voltage, 120 volts. So that is telling me that I do indeed have voltage across 8 and 2. So we verified so far that we have power, 120 volts on 8 and 6. Well, 6 goes directly to one side of our fans. 8 has to go through the purple, right here, close 2, and then from 2 we have a click sign or a fan delay. This allows our coil to get to a certain temperature before we call for fans. This is a switch as well. It has to close before we get power to 7, which then sends power to the other side of our fans. So we need to make sure before these fans run, we have to have a closed circuit completely. We know this is closed and is doing what it's supposed to be doing. Now we have to make sure that this is closed. I have my suspicions that it's not, because if it were, then I would have fans. And the graph that I looked at before I got over here, I noticed that these fans stopped working when coming out of a defrost. So I had my suspicions that it would either be the relay, which kills the fans in defrost, or the click sign, which delays the fans after a defrost to ensure that that coil gets cold enough before we kick our fans on. Any kind of moisture, anything that's on that coil, if those fans kick right away out of defrost, we can get a lot of snow in the case. We can get we can freeze up our coils that way. Now what we need to do is check across this. So we know that we have power from 8 to 2, so we can simply check from our terminal 2 to this terminal 7. If it is closed, we will have 0 volts. If that's the case and we still have no fans, then I would say we have a broke wire somewhere between here and there, or a broke connection. Not necessarily a wire, but it could be a connection. But if we have 120 volts between here and here, then I know that this click sign is indeed open. Now that's gonna open and close at a certain temperature, but just from experience, I know that this coil has been running long enough, and the ice pattern, the frost pattern that I see on this coil should be cold enough to close this click sign. So let's check. Alrighty, so we have lead on 2, we have our other lead on 7, and what do we see right here? We have 120 volts. So that's telling me immediately that we have a Clixon that is open. If you want to see what this looks like, we notice right here, this is one side of our Clixon. It goes through right there, comes back out to complete the circuit to send it down to our terminal bus 7 to send it right back to the fans. So this one has been changed in the past. How long ago? I do not know, but I can guarantee you that this is our culprit. Now, if you do not have a Clixon in the truck, you can jump these out temporarily, but you don't want to leave it running this way. You want to make sure you come back and you add the proper parts. We want these things to run at spec. We want to delay the fans after defrost, and we sure don't want, you know, ice buildup and snow in the case. It gets all over the product. It's hard to deal with. It can disturb airflow. So with that being said, temporarily to get these guys running, I mean, they got to make sales. So we can jump these wires together by simply wire nutting one side to the other. Remember, it's just a switch. So we're just closing the circuit. This is not a load, this is a switch. So we're just closing the switch manually, and these fans will kick on. Let me go find a breaker. We'll do it safe. We'll get it jumped out. Once it's jumped out, I'll show you, and we'll see these fans rock and roll. I want to point out something about these cases. I just absolutely love these cases for this one reason. Look at the distance between the hand valve and the TXV. I mean, if you want to clean these screens, it takes hardly no time. And look, this is what I like also. A handy dandy port in between the two. I mean, it doesn't get any quicker than that. That's just awesome to me. Anyway, we'll be back in a minute. Go ahead and say something before I walk away from this case. If you noticed, I went ahead and shut this panel right here. The last thing you need is some little kid coming along and sticking their fingers in a panel, and you would be to blame for it. So before we walk away from this stuff, do your best to eliminate any risk or any problems. Alright guys, we got the breaker off, so we're not going to take the breaker's word for it. What we're going to do is verify. I've in the past not verified, and it hurts. Get shocked. So 8 and 6 is our power. Give me a second. Okay, here we go. 8 and 6. No juice. Check it to ground. No juice. Okay. So we are ready to bypass this fan cycle. I don't have one on me, but that's all right. I will return to put one, because I'm a firm believer in these things. I've seen cases freeze up, nobody could figure out why. Fan delay. Okay, so what we've done right here, this is not live, this is no power to it. We've essentially bridged the gap that this Clixon is supposed to close, and bridge the gap here. Well, we did it manually. That's all we need to do. Put a wire nut on it. What we're gonna do, I know this is kind of crazy, but I like to tape these ends up, wire nut them, dead end them some way, because even though we know that there's no power on this whatsoever, somebody else might not know. So you know, we just want to make sure that if I come behind somebody and I see exposed wires, I'm gonna wonder, whoa, why is this exposed? Well, we don't want someone going down a rabbit trail 15-20 minutes trying to figure out why these wires are exposed, and trying to figure out why and what and how do I kill it, and is it even safe to work on. We'll go ahead and just get rid of the confusion right away. All right guys, we got fans back running. We have our valve back open. TXV's feeding fine. do need to come back with the new clicks-on fan delay. I think that about wraps up the call. We'll verify airflow. It'll be a little low right here without the pan in, but let's keep going. Want to verify airflow, you know, throughout the case, just to make sure. Okay, our tip's already coming down. When we first started, it was about 35-40 degrees, so it's coming down quite nicely. I think that pretty much wraps up the call. We'll get this sewed up and that'll be it. Oh, I want to show you something. Have you guys ever seen a pizza roll turn to powder? Goodness gracious, that's gross. So these are the types of objects that get stuck in our drains. We know it's not our duty to clean these cases. The store is supposed to be cleaning these cases and maintaining their equipment. However, if you open up a case, save yourself a nightmare, save yourself a lot of calamity just by taking out a few items that you can see, that you can reach, that would clog up a drain, that would cause a service call. The store may never notice, so you may not get thanked for it, but it doesn't matter. I mean, it's not about getting thanked, it's about servicing the store and really saving yourself a headache in the future. You know, you want to be a good technician. You don't want to have a lot of callbacks, because I'm gonna tell you something. If one of those things fall in the drain and it clogs up that drain, and you got a frozen case, and you just worked on this case a week ago, a totally different problem and really not your own fault, you're gonna be to blame for that case freezing up. So just, if you touched it last, whoever touched that, isn't that the rule? Whoever touched it last messed it up. So just save yourself some calamity. All right, until next time, HVAC Preacher, we praise the Lord Jesus Christ, and we'll see you at a different time, different service call.